welcome to lecture series of Mathematics 1. This is Hitesh Maulani, Assistant Professor at LJ Institute of Engineering and Technology. So today we will discuss about different forms of Taylor series. So in the last lecture we have discussed about Taylor series of function f of x is given by f of x is equal to f of a plus x minus a raised to 1 divided by 1 factorial f dash a plus x minus a whole square divided by 2 factorial f double dash a plus so on plus nth term will be x minus a raised to n divided by n factorial fn a plus so on. So this is Taylor series of function f of x. Now suppose if we replace x minus a by h, so if we replace x minus a by h, then x will be a plus h. So x will be a plus h. So here we will replace x by a plus h. Okay. So this series will be f of a plus h is equal to f of a plus what is x minus a? It is h, so it will be h raised to 1 by 1 factorial f dash a plus h square by 2 factorial f double dash a plus so on plus nth term will be h raised to n divided by n factorial fn a plus so on. So this is different form of Taylor series in which suppose given function is a plus h type and we have to express that function in ascending powers of h, then we will use this Taylor series. Okay. Now suppose we put a equal to x. So replacing a by x, we will get f of x plus h is equal to f of x plus h raised to 1 by 1 factorial f dash x plus h square by 2 factorial f double dash x plus so on plus h raised to n by n factorial fn x plus so on. So this is another form of Taylor series, and this will be useful if we have to express the function which is x plus h type and we have to express this function in ascending powers of h, then we will use this Taylor series. Now interchanging x and h, so if we interchange x and h, then here it will be f of h plus x is equal to f of h plus x raised to 1 by 1 factorial f dash h plus x square by 2 factorial f double dash h plus so on plus x raised to n by n factorial fn h plus so on. So suppose we have to express the function which is x plus h type and we have to express this function in ascending powers of x, then we will use this Taylor series. Now let us discuss example related to function which is a plus h type. So express cos a plus h in powers of h and hence find the value of cos 44 degree. So here first of all we will have to express this function in powers of h. So as discussed earlier, Taylor series of function a plus h is given by f of a plus h is equal to f of a plus h f dash a by 1 factorial plus h square by 2 factorial f double dash a plus so on, plus nth term will be h raised to n by n factorial f n a plus so on. So here, as you can see, given function is a plus h, right? So here f of a plus h is equal to cos a plus h. Now we will have to find out f of x. So here we will first find out f of x. So for that, replacing a plus h by x. So we will replace a plus h by x. So f of x will be cos x. Now here, as you can see in the Taylor series, first of all we will have to find out f of a. So here f of x is equal to cos x. So f of a will be cos a. Okay. Now second step, we will have to find out f dash a. So for that, we will take derivative of f of x. That means derivative of cos x with respect to x will be minus sin x. Yeah. Now here we will have to find out f dash a. So replacing x by a, so it will be minus sin a. Now we will have to find out f double dash a. For that, taking derivative of f dash x with respect to x. So derivative of sin x with respect to x will be cos x. So it will be minus cos x. Again, replacing x by a, because we will have to find out value of f double dash a. So here it will be minus cos a. And so on. Now putting these values in the Taylor series. So cos, what is f of a plus h? It is cos a plus h. So here it will be cos a plus h is equal to f of a. What is value of f of a? It is cos a. So here we will write down cos a plus h. What is value of f dash a? It is minus sin a. So here we will write down minus sin a plus h square by 2 factorial, and value of 2 factorial is 2. Yeah. And then f double dash a. What is value of f double dash a? It is minus cos a. So here we will write out minus cos a. So if we go further, then again we will take derivative of this term, that is minus cos x. So if we take derivative of cos x, that will be minus sin x, and minus minus, that will be plus. Okay. So next term will be plus. So we will write down plus, so on. This is expression of function cos a plus h in powers of h. So this is Taylor series of cos a plus h in powers of h. Now we will have to find the value of cos 44 degree. So to find the value of cos 44 degree, we will replace a by 45 degree and h by minus 1 degree. Because if we replace a by 45 degree and h by minus 1 degree, then here 45 degree minus 1 degree, it will be 44 degree. Okay. But here we will have to convert this degree into radian. So 1 degree, that means pi by 180 radian. So here we will have to multiply by pi by 180 to convert into radian. So minus pi by 180. So value of this is minus 0.0174. So this is value of h. Now replacing all these values, so here it will be cos 44 degree is equal to cos 45 degree, and here value of h, that is minus 0.0174, and here it is minus sine 45 degree plus minus 0.0174 whole square divided by 2 minus cos 45. So value of cos 45 is actually 1 by root 2. Cos 45 degree is 1 by root 2, and 1 by root 2, that means 0.7071. So we will have to replace cos 45 by 0.7071, as well as value of sin 45 will be same, because sin 45 and cos 45 both are 1 by root 2. Okay, so here we will write down 0.7071 plus minus 0.0174 minus 0.7071 plus, this will be as it is, minus 0.0174 whole square divided by 2 minus 0.7071 plus so on. So if we simplify this, then final answer will be 0.7193. So this is our approximate value of cos 44 degree. Hence this way we can evaluate values for different angles. Now let us discuss second example, in which function is x plus h type. Expand sin x plus pi by 4 in powers of x. So here we will have to expand this function in powers of x. So as we have studied earlier, Taylor series of function x plus h is given by f of h plus x f dash h plus x square by 2 factorial f double dash h plus so on, and the term will be x raised to n by n factorial f n h plus so. So here first of all we will have to find out the value of h. So here given function is f of x plus h type. So we will compare the given function with f of x plus h. So value of h will be pi by 4. If we compare, then value of h will be pi by 4. And now we will have to find out f of x. So for that, replacing x plus h by x. So here, if we replace x plus h by x, then here we will have to replace x plus h by x. So here it will be sin x. So f of x is sin x. Now first step, we will have to find out f of h. So f of h is equal to sin, replacing x by h, that is replacing x by pi by 4, because value of h is pi by 4, and sin pi by 4, that is 1 by root 2, which is 0.7071. Now second step, we will have to find out f dash h. So for that, taking derivative of this function, that is sin x, derivative of sin x with respect to x will be cos x. So f dash x is equal to cos x. Now finding the value of f dash h, for that replacing x by h, so we will replace x by pi by 4. So cos pi by 4, and value of cos pi by 4 is 1 by root 2, which is 0.7071. Now again taking derivative of f dash x, taking derivative of f dash x with respect to x, that means derivative of cos x with respect to x will be minus sin x. So here f double dash h will be minus sin pi by 4. That means minus 1 by root 2, which is minus 0.7071, and so on. Okay, now putting all this value in this Taylor series. So here it will be sin x plus pi by 4. That is our function f of x plus h. Then f of h, value of f of h is 0.7071. So here we will write down 0.7071 plus x into f dash h. Values of f dash h is 0.7071 plus x square by 2 factorial. F double dash h, value of f double dash h is minus 0.7071. So if we take derivative again for f triple dash x, then derivative of sin x will be cos x, and here it is minus sign. So here it will be minus, so on. So this is expansion of function sin x plus pi by 4 in powers of x. This way we can expand function in powers of x. So in this lecture we have discussed about different forms of Taylor series. Thank you for watching this video. I will see you in the next lecture.